Alright guys, today's lesson is about approximating square roots. We've talked about perfect squares and square roots, so let's review that first. So a perfect square is the square of a whole number. So remember, your whole numbers are like 1, 2, 3, 5, 10, 11, whatever it might be. And so the whole number here is 3. 3 squared, meaning 3 times 3, gives us 9. And so 9 is the perfect square because it's a whole number that has been squared. We can also model this by drawing a square that has an area of 9. There's 9 little squares there because it's a 3 by 3 square. Okay? Then we've got the opposite of a perfect square, which is its square root. And the square root is a number when multiplied by itself equals your given number. And we use that little radical sign. So here, I'm looking for the square root of 9. That's my given number. So I want to know what number times itself or multiplied by itself will give me 9. Well, that's 3, because 3 times 3, or 3 squared, equals 9. Okay? All right, so let's look at a couple of examples of some perfect squares and their square roots. So, square root of 36. I want to know what number multiplied by itself will give me 36. I know that you've got to know that that is 6. Okay? Why is it 6? Because 6 squared, or 6 times 6, gives you 36. Okay? And so using that same thought process, what's the square root of 25? Well, what number times itself gives you 25? That number would be 5. Okay? Because we know that 5 squared, or if I expand that, 5 times 5 would give me 25. Okay? All right, so we're not always looking for the square root of a perfect square. Sometimes we have to find the square root of a non-perfect square. And when we're doing that, we have to approximate the value by identifying what two integers that square root would fall between. So let's take this first example. We want to find the square root of 14, and we're going to find that rounded to the nearest tenth. So let's think about the perfect squares that I might find on either side of the square root of 14. Okay, I know that the square root of 9 would be on the left side of that. Okay? Oops, that's a horrible radical sign. But the square root of 9, which equals 3. Okay? And if I go to the other side of 14, let me think of the next perfect square. Well, if I look at 4, okay, that would be the square root of 16. So the square root of 14 falls between the square root of 9 and the square root of 16. And if I kind of judge where that is on this number line, well, 14 is closer to 16. Okay, so it's going to be probably somewhere about here on my number line. Okay. And so I know that my square root of 14 has to be somewhere between 3 and 4, and it's probably going to be closer to my 4. So I want to go above 3.5, so maybe 3.7, 3.8, somewhere in there. Alright, so from here it's kind of a guess and check. So I worked out my math for 3 7/10 squared and 3 8/10 squared. So I did 3.7 times 3.7, and I got 13.69, or 13 69 hundredths. I also did 3 8/10 times 3 8/10 to get 14 44 hundredths. So to decide on my answer rounded to the nearest tenth, I want to know which one of these gets me closer to 14. Okay? And so 13 69 hundredths is closer to 14 than 14 44 hundredths. And so I would say that the square root of 14, okay, is approximately, because it's not exactly equal, it did not come out to 14, so I'm going to use the sign for approximately 3 7/10. So rounded to the nearest tenth, the square root of 14 is approximately 3 7/10. Let's try another example. Alright, so our next example, we're finding the square root of 51, and we're going to round our answer to the nearest tenth. Okay, so again, I want to think about which two square roots would be on either side of the square root of 51. Okay, well, I know the square root of 49 would be smaller than it. Okay, so that's 7 on my number line. And then I need the next perfect square. So the next perfect square would be the 8 squared, which would give me here the square root of 64. Okay, and so the square root of 51 falls between these two, and I want to gauge where it's going to be on the number line. I know 51 is closer to 49, and so I need to be somewhere over here, meaning that the square root of 51 is going to come out closer to 7, so maybe 7.1, 7.2, and we'll just have to work through the math of those to see which one is closer. Alright, so I'm going to first try 7 1/10 squared, so 7.1 times 7.1.
1 times 1 is 1, 1 times 7 is 7. I'm going to hold the place there with the 0. 7 times 1 is 7. 7 times 7 is 49. Add that all up. 1, 14, 10, 5. I have 1, 2 numbers behind the decimal in the problem, 2 numbers behind the decimal in the answer.
I got 50 and 41/100ths. That's kind of close to 51, but I might be able to get a little closer. So I'm going to try out 7 2/10 squared also. So 7 2/10 times 7 2/10.
2 times 2 is 4. 2 times 7 is 14. Hold the place there. 7 times 2 is 14. 7 times 7 is 49. Plus 1 is 50. I'm going to add that all up. 4, 8, 1, 5. 2 numbers behind the decimal in my problem. 2 numbers behind the decimal in my answer.
So now I need to see which one of these is closer to 51. And if you need to, you can do the subtraction. But I know 50 and 41/100ths is about 6/10 away, whereas 51 and 84/100ths is about 8/10 away. So I'm going to go with the one that is closer to 51. So that means that my square root of 51 is approximately, because it did not come out all the way to 51, okay? So it's approximately 7 1/10. Okay? Alright, so I want you to pause the video here, try the next example on your own. Alright, so you were supposed to find the square root of 22 and round that answer to the nearest 10. Your two perfect squares on either side would be the square root of 16 or square root of 25, which means that the square root of 23 has to fall between 4 and 5. Okay? And it's closer to 5, so you're probably going to try like 4.8, 4.9, somewhere in there. Well, if you do 4.8 squared, or 4.8 times 4.8, we get 23 4/100ths. I don't think we're getting... Oh, am I doing square root of 23 or square root of 22? I guess I'm doing the square root of 23. Oh, my mistake. So you found the square root of 23. I don't think we're getting any closer to 23 than that. Okay? So our square root of 23 is approximately 4 8/10. Alright? So before you end your time with the video, you need to make sure that you do your summary. For your summary, you should be answering the question, how is knowing your perfect squares helpful in approximating the square root of non-perfect squares? Okay? So with each example, we used perfect squares. Tell us how that's helpful in approximating non-perfect square roots. Alright? Have a good day. Bye.